Let's say that we're told that this sum right over here, where our index starts at 2 and we go all the way to infinity, that this infinite series is negative 8 fifths plus 16 over 7th minus 32 over 9 plus, and we just keep going on and on forever. And so what I want to do is to explicitly define what a sub n here is here. So right now we just said, hey, if you take the sum of a sub n from n equals 2 to infinity, it turns out you get this sum right over here. But let's think about what a sub n, how we can actually define it in terms of n. And I encourage you to pause the video right now and try it on your own. So the first thing that you might realize is, well, this is the number that we're going to get. This is the number that we're going to get. Let me write it this way. A sub 2 is equal to negative 8 fifths. A sub 3 is equal to 16 over 7. A sub 4 is equal to negative 32 over 9. And I'm just giving the sign to the number in the numerator. Negative 8 fifths is the same thing as negative 8 over 5. Let me make that a little bit clearer. So make that a little bit clearer. So this is negative 8 over 5. Obviously, this is positive, so I don't have to really worry about too much. And then here, I'm just saying negative 32 over 9 is the same thing as negative 32 over 9. So let's see if we can first find a pattern in the numerator. So when we go from negative 8 to 16, what's happening? Well, we're multiplying by negative 2. Now to go from 16 to negative 32, we're multiplying by negative 2 again. So you might say, okay, well, whatever we have in the numerator must be a power of negative 2. All right, if you say, well, maybe this is negative 2 squared. Well, you know that negative 8 isn't negative 2 squared. Negative 2 squared is equal to positive 4. Negative 8, this right over here, negative 8, that is equal to negative 2 to the third power. 16 is equal to negative 2 to the fourth power. Negative 32 is equal to negative 2 to the fifth power. So notice, our exponent on the negative 2 is always going to be one more than our index. Our index is 2, our exponent is 3. Our index is 3, our exponent is 4. Our index is 4, our exponent is 5. So that gives us a sense, at least the numerator is going to be whatever our index is, it's going to be, so let me write this down. So a sub n is equal to, well, it's going to be negative 2 to whatever index we're at, to that index plus 1 power. So that's one way to think, or that's a reasonable way to think about our numerator. Now let's think about our denominators. So so we go from 5. So when n is 2, we're at 5. When n is 3, we're at 7. When n is 4, we're at 9. So notice, 5 is 2 times 2 plus 1, is 2 times 2 times 2 plus 1. This right over here is 2 times 3 plus 1. This right over here is 2 times 4 plus 1. And you should just kind of play around with different patterns in your head until you say, hey, well, look, this is increasing by 2 every time. Notice this increases by 2 every time. But these aren't exactly multiples of 2. These seem to be off of 1 more than the multiples of 2, which is a good sign that this is going to be 2 times our index plus 1. So we could write this down. As 2 times our index plus 1. And we're done. That's what a sub n is. And if we wanted to write this series in sigma notation, we would write this as a sum from n equals 2 to infinity of negative 2 to the n plus 1th power over 2n plus 1. And that would equal this series right over here.